Somewhere outside Beijing, in a lab most Americans will never hear about, engineers just powered on a chip smaller than your thumbnail and watched it do something no radio on Earth has ever done in a single breath. Reach every useful frequency from microwave range all the way up into terahertz territory and push more than 100 gigabits of data through that connection every single second. Your phone, right now, on a good day, on the best 5G tower in the best city in America, is not touching that number. Not close. Stick with me, because by the end of this video, I'm going to show you exactly how close it actually is, and the honest answer is more interesting than the headline you clicked on to get here. This is Iron Circuit, and if you've been here before, you know the rule on this channel. I don't repeat a number unless I can trace it back to something real. So before we go any further, hit subscribe right now because in the next few minutes I'm handing you the actual research, the actual scientists, and the actual gap between what China just built and what 100 times faster really means. That way, the next time a headline like this shows up in your feed, you'll already know exactly how to read it before anyone else explains it to you. Here's what actually happened. A team led by Professor Wang Xingjun at Peking University, working with researchers at the City University of Hong Kong, built something they're calling an all-frequency chip. It measures 11 millimeters by less than 2 millimeters. That's smaller than your thumbnail, smaller than the SIM card sitting inside your phone right now. And inside that sliver of material, they pack the ability to operate across the entire usable wireless spectrum, from half a gigahertz all the way up to 115 gigahertz. To put that in perspective, your 5G phone lives inside a tiny sliver of that range. Satellites use another sliver, further up. Future technology like remote robotic surgery would need a sliver near the very top. Normally, covering that entire range takes 9 separate radio systems, 9 different sets of hardware, each one built for its own narrow lane. China just put all 9 into a single chip. That's not an upgrade. That's a redesign of what a radio even is. But here's the part almost nobody explained when this story broke. How do you build one piece of hardware that can jump between frequencies that far apart without falling apart the way every previous chip design has? The answer looks almost nothing like a normal radio. Instead of pushing an electrical signal straight through a wire the way your phone does right now, this chip converts the wireless signal into light first. It runs that light through a material called thin-film lithium niobate, using something called a broadband electro-optic modulator, and a set of oscillators takes that light and turns it back into an extremely clean, extremely stable radio signal, anywhere across that entire spectrum. Think of a normal radio chip like a musician who owns 9 different instruments and has to physically put one down and pick another one up depending on the song. This chip is one instrument that reshapes itself into any of them instantly, using light instead of muscle memory. In testing, it returned across 6 full gigahertz of bandwidth in 180 microseconds. That's faster than a human blink, by a margin so large it's barely worth comparing. Picture the actual test bench for a second. No visible motion, no spinning parts, nothing that looks remotely dramatic. Just a sliver of material under lab lighting, cables running to a bank of instruments, and a screen quietly logging numbers that, if they hold up outside that room, rewrite what a phone chip is capable of. Here's why any of that should matter to you personally, and not just to an engineer in a lab coat. Every piece of future technology people keep promising you. Cars that drive themselves through intersections without a human touching the wheel. Surgery performed by a robot arm controlled by a doctor on another continent. Glasses that overlay real-time information on the world in front of you. All of it depends on a wireless connection with almost no delay and almost no dead zones. 5G was supposed to deliver that. In most American cities, it still hasn't, not consistently. A chip that can seamlessly jump across the entire spectrum instead of getting stuck in narrow lanes is exactly the kind of hardware that finally makes those promises technically possible instead of just a slide in a keynote presentation. To understand why this particular breakthrough matters, you have to understand where China actually started. Through the 2G, 3G, and 4G eras, China wasn't setting the rules of wireless technology. It was following them, building networks on standards written mostly in Europe and the United States, and paying licensing fees for the privilege. 5G was the first generation where that changed. Chinese companies, Huawei chief among them, went from adopting the standard to co-writing it. And by the time 5G networks were rolling out worldwide, Chinese firms were sitting near the top of the list of companies holding the actual patents other countries' phone makers had to pay to use. 6G is the generation where China isn't trying to catch up to that position anymore. It's trying to start there, a full generation ahead of where it began, and a chip that can already hit 6G's target speeds on a lab bench is exactly the kind of proof point a country points to when it wants the rest of the world watching who's actually ahead. Now here's the number the headline actually promised you. Single-channel data rates above 100 gigabits per second. The team's own reporting framed that as up to 5,000 times faster than what people in rural American communities actually experience on their phones today. 5,000, not 100. And a number that large should make you suspicious, because massive figures like that are exactly the kind of thing that gets quietly rounded up, exaggerated, or ripped completely out of context by every channel chasing the same headline you're watching right now. So let's slow down and actually stress test the claim in this video's own title, the same way I stress test every number before it goes into a script on this channel. The 100 times faster figure isn't actually a measurement of this specific chip at all. It's the general industry benchmark for what sixth-generation networks are expected to deliver once 6G is running at real scale, across the whole world, years from now. This chip, in a lab, under test conditions, hit data rates that fit comfortably inside that expected range. That's a real, measured, published result, and it deserves credit as one. What it is not is a nationwide 6G network quietly switched on under American cities while nobody noticed. There is no 6G phone in anyone's pocket right now, in China, in America, or anywhere else on Earth. This is a chip on a lab bench, proving the underlying physics actually works. And that distinction matters, because it's exactly where most of the internet stops being honest with you. Here's the scorecard, the part most coverage of this story skipped entirely. What's real? The chip exists, it's published, peer-reviewed research. It comes from a named professor at a named university. And the spectrum coverage and speed numbers are measured lab results, not a marketing slide at a trade show. What's exaggerated? The idea that this is a working 6G network you could connect to this afternoon. It isn't, and it won't be for years. 5G itself is the fair comparison here. The first working 5G lab demonstrations happened years before a single commercial 5G tower switched on, and even after launch, it took most American carriers the better part of a decade to deliver the coverage they promised on day one. 6G, at the pace this field usually moves, is realistically not landing in your pocket before the early 2030s, regardless of which country's lab gets there first. What's still unsolved, shrinking this lab result into something that survives being mass-produced by the billions, dropped, overheated, frozen, and crammed next to a battery inside a phone that costs less than $1,000. There's also a physics problem headlines never mention. The higher you push into that spectrum, toward millimeter wave and terahertz, the worse the signal gets at traveling through walls, rain, or even thick fog. That's the same wall that slowed 5G's rollout across the United States for years after it was first announced. A chip that proves the physics works once on an optical bench, and a network that survives real weather, real buildings, and real manufacturing at Apple or Xiaomi scale are separated by exactly the kind of engineering years that have quietly killed plenty of promising lab breakthroughs before they ever reached a store shelf. This also isn't the only piece of the puzzle China's been quietly assembling. Separate teams, including China Mobile and researchers at Southeast University and Fudan University, have already run early terahertz trial networks in and around Beijing, pushing peak download speeds reportedly north of 1 trillion bits per second in short-range tests. That's a different project, testing a different piece of the puzzle, a live network trial instead of a single chip. But put next to each other, a chip that can tune across the whole spectrum instantly, and a live trial network already pushing terahertz speeds in the real world, and you start to see less of a single headline and more of a coordinated build-out, with multiple teams attacking multiple pieces of the same problem at the same time. So where does that leave the actual race hiding underneath this headline? Because China didn't stumble into this by accident. Sixth-generation wireless sits inside China's official 5-year plan as a named strategic priority, backed by direct state funding aimed specifically at terahertz spectrum, satellite communication, and the exact chip technology this video just walked you through. When a government treats a wireless standard the same way it treats a highway system, funding moves faster and bigger than any single company would ever risk on its own balance sheet. And it shows in the numbers that actually matter long-term. By most patent tracking available right now, China holds a meaningful lead in 6G-related patent filings over every other country on Earth, the United States included. Now, before this turns into another lazy America is asleep video, because it genuinely isn't, here's the honest picture on this side of the Pacific. The next G alliance, backed by AT&T, Verizon, T-Mobile, Apple, Google, Qualcomm, Microsoft, Samsung, and Ericsson, exists specifically to keep North America competitive on 6G standards. Federal agencies, including the National Science Foundation, DARPA, and funding tied to the CHIPS Act, are pushing roughly $3 billion into the underlying research right now. Intel is running its own dedicated terahertz communication research effort. Apple already runs an internal 6G device program of its own. This is not a country doing nothing while China sprints ahead. It's a country running the same race through a coalition of private companies and federal grants, instead of one centralized national plan with a single set of hands on the wheel. Two completely different systems, chasing the same finish line, and right now, the centralized one is simply moving faster. And that difference is the real story here, more than any single chip ever could be. Rewind to the 5G race for a second, because this has happened before. The companies and countries that controlled the core 5G patents didn't just win bragging rights. They collected licensing fees from nearly every phone manufacturer on the planet for years afterward. Huawei alone walked out of that race as one of the largest holders of 5G standard essential patents on Earth, a position worth billions in royalties regardless of how many Huawei phones ever sold in the West. Whoever writes the 6G rulebook next doesn't just get a headline moment in a lab. They get to collect rent on every phone, every cell tower, and every satellite that follows their standard for the next 2 decades. That's not an abstract cost either. Standard essential patent fees get baked directly into the price of every phone sold under that standard, which means the country that wins this race doesn't just win prestige. It quietly taxes your next phone upgrade for a decade, no matter which brand's logo is on the back of it. There's a national security layer sitting underneath all of this too. Whoever controls the core 6G standard also controls a piece of the infrastructure that future defense communications, satellite networks, and secure military systems will eventually run on, which is exactly why Washington treats this as more than a consumer technology story. So here's what to actually watch from here, instead of just reacting to the next headline. Watch whether this chip design shows up in an actual manufactured device, instead of staying a single lab prototype, because that's the real line between a breakthrough and a demo. Watch whether the terahertz trial networks in Beijing keep scaling towards something resembling a real coverage area instead of a short-range test. And watch whether the Next G Alliance responds with a comparable, publicly demonstrated result of its own. Because right now, the loudest public proof point in this entire race belongs to Beijing, not Washington. So here's where this actually leaves us. A real chip. A real named research team. A real measured result that lands well inside the range 6G was always expected to deliver. Not a live network. Not a phone in anyone's pocket yet. Not proof this survives mass production. But a genuine head start in the race to decide who writes the next 20 years of wireless rules, at a moment when the two countries chasing that finish line are running two completely different kinds of races. China is sprinting with a government directly behind it. America is running as a coalition of companies and federal grants. And the gap between those two approaches might end up mattering more than the chip itself ever will. So, which approach do you actually think wins a race like this? One centralized government pushing a single national plan, or a coalition of private companies moving independently toward the same goal? Tell me in the comments, because I read every single one, and I'm tracking exactly how this race moves from here. If you want the next update on this the moment it actually happens, and not 3 months late once it's already safe to report, subscribe right now. Because catching stories like this before they're mainstream news is exactly what this channel exists to do.